Welcome to Check on Ruler. So, step 1, go away face. Step 2, open, check on learning. Step 3, number 1, which of the systems shown could, oh, by the way, this is section 2.4, in case you were wondering. Anyway, which of the systems shown below could have two solutions? Explain your reasoning. So we've got a parabola and a line. Okay, you could have two solutions there. You have a circle and a line. You could have two solutions. You have a line and a line. You could definitely not have two solutions. So both linear quadratic systems could have two solutions. The linear system cannot have two solutions because two lines can never intersect at exactly 2 points. There can only be one intersect, at least in Euclidean geometry. Let me check my answer. This is 2.4. Check understandings. The first and second systems, both linear quadratic systems, could have two. Yeah. So there you go. Use the following system. Solve the system graphically. Which of the following is the correct graph of the system? So we're going to use a little bit of our testing strategy here. You could check these using a graphing calculator, but this is a parabola. It's facing up. It moved up at least one or 2 units. I'm sorry, down 2 units. So that one could be it. That one could be it. That one could not be it. So we're in these two. So we look at our line. Y equals, okay, I'm going to change that to y because it's x plus b. So y, that's a cool y, equals 1.5x plus 4. So I move this over, I move this over. So now our y-intercept is going to be at 4. So now I can look at this and go, I like that one. That one's wrong too. So let me look at my answers here. So the answer in the book is totally different. But I stand by what I said. I like that one better. Yeah, they must have been doing a different problem. That's awesome. Anyway, so use the graph in part A and approximate to the nearest tenth if necessary. Which of the following is the correct solution to the system? So where does it cross? So I would say our x, that's -5, so that means that's going to be 2.5. I don't know, at x equals like 1 or 2. What are my options? So there's a -1.5 I think I saw. So -1.5. I'll go with that one. Yeah. And again, you can check this for real with a natural graphing calculator. All right, let's see here. When do I get to do some math? Solve the system graphically. Which of the following is the correct graph of the system? So, just to show you one other way of solving these using a graphing calculator, or at least a graphing function, whatever. So this is that wonderful Desmos website. So the joys about the website is I can copy. It never gets the squares though. Oh, get this one. So that's our graph. That's what we're looking at. So when we come back here, solve the system graphically. That one kind of looks right. Ooh, I'll have to check that. So my intercepts here looks like a little less than -4, a little bit more than -2, a little bit less than -4, a little bit more than -2. So this one down here has a similar shape, but it's greater than -4, or I guess less than -4. So it's not that one either. So we'll stick with that one. Use the graph in part A and approximate the nearest tenth if necessary. Which of the following is the correct solution for the system? So we can come up here, and the Desmos you can get real close on. It works very much, well, I think very similar to like how like your iPad would work or whatever. So -0.8 and -8. -0.8, -8.6. And I would kind of go with that one. Where's our second one? -6. -19. Yeah, I'll agree to that. So there you go. Okay, now we actually get to do some math. So it says solve the system by substitution. So this is a great example of how to use substitution. So here we go. We already have a y equals, actually we have two of them. So we're just going to take this bottom one and we're going to plug it in everywhere where we see y up on the top one. So it simply turns out that it's going to be 2x plus 1 equals x squared minus 5x plus 7. So we didn't just set them equal to each other, we substituted in for that y. So just so you know. Okay, so now we need to get this 0 equals blah, 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 x squared, blah, 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 blah. So we're going to move all of this over to the other side. So that's going to be minus 2x minus 1 minus 2x on this side minus 1. So we're going to have 0 equals x squared minus 7x minus plus 6. Yeah. So believe it or not, this is factorable. Makes my life easier. So we're going to factor it as opposed to using a quadratic formula because factoring, in my opinion, is easier and involves less math. So we've got our x, our sine. Oh, well, that sign tells me that both of these signs are going to be the same. This tells me that they're both going to be a negative sign. So we've got a negative, negative. Our multiples of 6 are going to be 1 and 6. So 1 times 6 is 6. And then 6 plus 1 is 7. And of course, if you add the negative signs in there, we are good to go. So all of that equals 0. So from there, I can say my solution is whenever this equals 0 and whenever that equals 0. So x minus 1 equals 0, x equals 1, x minus 6 equals 0, x equals 6. Oh, I'm not done yet. So I've got two x points. Now I need the corresponding y points. So for x equals 1, we're going to plug our 1 back into this initial equation because it's the easier one. So we've got y equals 2 times 1 plus 1, which equals 3. So our first answer is what? A point called 1, 3. Let me make sure that it's right. Oh. 1, 3. Our second point, we're going to plug in our x equals 6 right here. So now we're going to have y equals 2 times 6 plus 1, which equals 12 plus 1, which equals 13. So then my second point is going to be 6, 13. And checking the answer, 6, 13. Finally get to do some good, wholesome math. So solve the system by using substitution. So this is actually a situation where you would have to use substitution. Well, you didn't have to, but it's easier to do so. So what we're going to do is we're going to rewrite this equation so that it's y equals 3 over 4x. Oh, this is going to get fun. So I just divided both sides by 4. So now we're going to plug that into our first equation. And again, we're going to have 3 over 4x squared equals negative x squared plus 25. So if we square our left side, we're going to have 9 over, what is 4 squared? 16. I knew that. I'm just testing. X squared equals negative x squared plus 25. So we'll move everything, I mean, I don't even care. I guess to the right, I'm sorry, to the left. So we're going to have 9 over 16x squared plus 1x squared minus 20 equals 0. So then we're going to combine those x squareds. So I'm going to rewrite this one as 16 over 16 so that my denominators match. So then 9 plus 16 over 16 x squared minus 20 equals 0. That 20 is going to end up going back over to the other side, looks like. Did I drop an x somewhere? No, I didn't. Just checking. Anyway, so we need to get x squared by itself. So, and then I'm going to combine these two. So that's going to be 25 over 16x squared equals 20. We're going to multiply both sides by the reciprocal. over 25. So then we're going to have x squared equals I don't know what 20 times 16 is. So what is that? 120, 320? Is that right? Did I get it right? Did I get it right? 20 times 16. Ha! It's 320 over 25. Yay! 320 over 25. So then we take the square root of both sides. Means we're going to have a plus or minus. So then we're going to have x equals, I wonder if 320 is a, it's not. That's annoying. 25 is a perfect square root. So we're going to have square root of 25 over square root of 320, which is going to equal so I just in my calculator, I'll do it on here. So I didn't know what 320 is divisible by for a perfect square root. I had a hunch that it was 4. So I took 320 and I was like, well, it's even, might as well try 4. So divided by 4 is 80, it's still even, divided by 4. So that means that I can pull a 4 squared out, and I'll have 20 left over. So I'm going to have 5 on the denominator, and then 4 square root of 20. I don't think, oh yeah, you can take another 4 out. So then, here's our answer. So then we would have 4 times 2, forgot 4 is a perfect square. 5, square root of 5, over 5, which is going to equal 8 square root of 5 over 5. Plus or minus, of course. So let's see if looks like I did something wrong. So 16 over 25. Oh, I just magically, did you see this? Right here. I just magically turned that 20 into a 25, or into a 20. So I'm going back through. I'm in red now, so you'll be able to see the changes that I make. So this should have been 20, come on, 25, and then I'm just going to erase everything after that. You know you guys are supposed to make sure I don't make these mistakes, right? Did all that extra work for nothing. So we are moving the 25 over 16 to the other side. Our 25s cancel out. Then we have x squared equals 16, which is way easier to deal with. So then we take the square root of both sides, and we have x equals plus or minus 4. Duh. So then we have two x values. Remember, we have positive 4 and we have negative 4. I'm going to plug them back into this equation because, again, it's easier. I shouldn't have erased my y equals, but whatever. So our y equals 3 over 4x. So if I put in negative 4, y is going to equal negative 3. So negative 4, negative 3. Then if I put in positive 4, equal positive 3. See? There you go. And yes, I did check that answer. Make sure that it's right. Three more left. You can do it. All right, it says solve the system by elimination. So right off the bat, you're going to be adding or subtracting something. The first thing I see is that we have a y and a y. So since they're the same, that kind of makes for easy solving by elimination. So we're just going to line those up, and we're going to subtract the second one from the first one. So yeah, it doesn't really matter which one we do. So we'll just do a negative sign with this one, and I'm going to line it up over here on the right. So we've got, let's see here, y equals x squared minus 2x plus 2. So then our other one, so we've got a negative and negative. So we've got a plus 2x, we're going to move that over a little bit. So we've got a plus 2x, we've got a minus y, and that's going to be equal a plus 2. So I spaced it out a little bit weird, and I did that intentionally so that my like terms lined up. So I can then just very quickly go through, and I've got 2x, these guys cancel out, equals x squared minus 2x plus 2. So we're going to move our 2x over to the right. So we're going to have 0 equals x squared minus 4x plus 2. And let's see, can I factor that? No, I don't think I can, which is unfortunate. I wish I could have. But, so I can't. So I think at this point, unless I can think of any other way to do it, oh, we can factor that. What did I do wrong? Yeah, okay. I can't add. 2 plus 2 is 4. Who told me it was 2? So since that was 4, since that is 4, that we can factor. So again, we do our x and our x. This sign tells me that both signs are going to be the same. This sign is the sign that it's going to be. Our factors of 4 are going to be 2 times 2, but then also 2 plus 2 is going to be 4. It's going to give us that number. So there we go. So at this point, we have x equals 2. But that's only one solution. So 1, that makes sense because they only give us one spot. But 2, we know that in this case, this line is tangent to the parabola that we have. So that one is a parabola. This one is a line. And so, because we only got one x, we know that they're tangent. But anyway, I digress. So we take the x equals 2. We're going to plug it back into one of our original equations. I'm going to pick that one because, hey, it's easier. And I'll switch to black. So we've got negative 2 times 2 plus y equals negative 2. Probably could have set everything equal to y, or solved for y first, but whatever, it doesn't matter. So this is -4 plus y equals -2. So y equals +2 because we added 4 to both sides. So my answer is, oh, that's convenient, 2, 2. Let me check the answer real quick to make sure that that's right. I don't want to lead anybody astray. Yeah, so the solution is 2, 2. Can you guys hear the rhinoceros in the background? That's my kid watching her shows. So it says, solve the system by elimination. Which of the following are the correct solution? Cool. This will be fun. So it's by elimination again. So usually this book always kind of defaults to y, hint, hint. So we've got a y, we've got a negative y, which means you don't even have to change any signs. We can just add them together. So if we just add those together, we're going to have x, that's not an x, x, y's cancel out, equals x squared plus 6. Okay, so then we're going to move the x over. We've got 0 equals x squared. Yes, Molly? Okay, so here we are. We've got 6, -1. So I'm trying to see if that's factorable. Unfortunately, it's not. I almost thought that like 3 and 2 would get there, but because this is a plus right there, you'd have to add these two together, and that would be 5, not 1. If this was a minus sign right here, then I would get away with it, but it's not. So looks like we have to do this the old-fashioned way and use the quadratic formula. So I'm going to write it up here because I can never remember it. So it's x equals, what is it, b squared plus or minus square root, no, that's not. Man, what is the quadratic formula? Negative b, is it negative b plus or minus b squared minus 4ac all over 2a? I have to look that up. So that's what I told you before. I'm really bad at memorization. So, sorry. So yeah, negative b plus or minus square root of b squared minus 4ac. All over 2a. Okay. So our a equals 1, our b equals -1, and our c equals 6. So we're just going to plug that in. So x equals negative b, so -1, plus or minus the square root of b squared, which is just 1, minus 4 times 1 times 6, all over 2 times a. Okay, so if we simplify all that, we've got 1 plus or minus the square root of 1 minus, what is that, 4 times 6, which is 24, all over 2, which that equals 1 plus or minus square root of -23, all over 2, and that's, did I do something wrong? A, C, no, I don't think so. So, oh, the discriminant, I don't know why I was getting confused. So I was looking at these ones and going, oh no, none of those work. But if the discriminant is negative, what does that mean? If you're saying that the system has no real solutions, you are right. So we would do no solution. See, I thought that was going to get much harder, but yeah, so since this discriminant, which I knew that a long time ago, I just didn't put the connection together. So that's why that discriminant is super important. It helps you kind of figure those things out, hopefully before you do all the work, but, whatever. So what is this? Last but not least? Yes, last but not least. So the trajectory of an apple shot out by a cannon can be modeled by the quadratic formula blah, where x is the horizontal distance in feet an apple has traveled and y is the height in feet. The ground slope can be modeled by a linear function blah. Where will the apple land? Round your answer to the nearest tenth. So, to do a rough sketch, it looks something like this. You've got your cannon right here, and then your apple is a parabola that starts from your cannon. So we want to find that point right there. So it's just a system of equations. So we need to figure out where they cross or solve the system of equations. So here we go. Obviously, our first equation is this guy right here, and then we've got that guy right there. So we've got y equals, and we've got another y equals, blah, blah, blah. I'm thinking not substitution. Elimination would be the best bet because we can just subtract those two and then go from there. Obviously, we're going to have to use our calculators because it's going to get pretty nasty with some values like that. So we're just going to subtract that. So then we're going to have 0 equals 22 minus 20, so 2. And then we're going to have 0.16 plus 0.1. So that's going to be plus 0.26x minus 0.004x squared. So at this point, that's definitely not going to factor or anything crazy like that. So let's just shove it into the quadratic function formula, and we'll go from there. So negative b plus or minus square root of 4a, whoops, that's wrong. B squared minus 4ac all over 2a will solve this equation. Our a is equal to negative 0.004. Our b is equal to 0.26. And our c is equal to 2. Okay, so we've got negative 0.26 plus or minus square root of 0.26 squared minus 4 times a, which is negative 0.004, c times 2 all over 2 times negative 0.004. Hey, so let's do the calculator game, right? So first things first, I'm going to do the discriminant underneath the square root just to see what I get. Also, that kind of helps me make sure that I keep my order of operations right. So I'm going to do 0.26 squared minus, parentheses, I want all this to happen first, 4 times negative 0.004 times 2, close parenthesis. So that is a small number, but a positive number nevertheless. So we've got, and I'll write this off to the side, negative 0.26 plus or minus the square root of 0.0996 all over negative 0.008. So I distributed that 2 in because I could do that in my head. Woo! So we got to plug both of these in. So negative 0.26 plus a square root. You can use the second button to get to that square root right there. 0.0996. So on my calculator, you just push the right button and you get out of that square root. And I should have put that in parentheses because I want to add that divided by thing. So to insert something in, go to the spot you want to insert it, and your calculator automatically will just override whatever it's highlighted unless you push this insert button right here. So push second, delete, and that'll add my parenthesis divided by a negative 0.008. I don't know if I necessarily need that last set of parentheses, but I put it in there just in case. So I got a negative 6.95. So we'll say x equals negative 6.95. So now we want to do the negative, right? So there's a way to kind of help us out with that. Let's call this entry thing. So that entry is just going to take this whole equation and redo it. So there it is, and now I can go back through and just change that plus to a minus. And then I get, that's really interesting. But yeah, then I get a positive 71.95. Okay, what does that mean? Where will the apple land? Round your answer to the nearest tenth. So remember, our apple was shot by a cannon. So if it's shot forward, is this x equals negative 6.95 make any sense? It does not. And so, oh, hang on. So we can cross that one out. So now we just take this number and we're going to plug it back into really either one of our equations. It doesn't matter. So I'm going to write this one on the screen. We'll switch to blue. So y equals negative 0.1x plus 20. So we're going to plug that x into that. And again, just going to use my calculator. I know it's hard to see. Negative 0.1 times, this time I'm just going to use my answer, so it'll be slightly more accurate. That's my answer right there. What, plus 20? Was it plus 20 or 26? Plus 20. Where'd my calculator go? Plus 20. So our next answer is going to be 12.8. And it did say round to the nearest tenth, so I can say y equals 12.8. So our actual point is going to be 71, actually 72 if I'm rounding to the nearest tenth. Oh, let me check my calculator real quick. Okay, so it would still be 71.9 because that's a 4, so we wouldn't round that 9. So let's erase that 5 before I get confused myself. Oops. Anyway, so 71.9, and then our y would be 12.8. Let me double check the answer just to make sure I'm not steering anybody wrong. The apple lands at 72.5 feet away and 9.2 feet lower than the place where it was launched, since it started at a height of 22. Where did it say that? I guess if you throw x equals 0 into where the cannon was shot, it was at 22. That's the only thing I can say for that. So their y that they got the same number that we did. They got y equals 12.75. I'm trying to figure out why they decided that the apple lands. Oh, here we go. So this is correct right here. So which of the following correctly interprets the solution in terms of context? The apple lands 71.9 feet away and 9.2 feet lower than where it was launched, since it started at a height of 20 feet. Let's get all this stuff out. So I guess it was launched from 22 feet up, because again, if you shove x equals 0 in here, you get y equals 22, and that's where the cannon started. And so the apple lands 71.9 feet away horizontally, because that's our x value. And then at x equals 0, the hill is at 20, and then it ends at 12. So I'm assuming we just take 20 minus 12.8 or something like that. And that's where our 9.2 comes from. So we'll go with that. So that last part's kind of hard to do without an actual picture, and it was a little hard to glean that information from just this equation right here. They didn't really make that clear, but that's what they were kind of looking for. So the way I came about that, so the apple was launched from the cannon. The cannon clearly, so here's our hill, sticks out a little bit because the y at x equals 0 from our parabola, or our launch of the apple, has that 22 here. So at x equals 0, we've got our 22. whereas our linear function at x equals 0, y would be 20, and so our cannon starts just a little bit away before the apple goes. So hopefully that makes sense. Again, that's a little weird and convoluted, but we made it. So there you go. Check on learning finally complete. I'll see you in class.